two things, but they're both about segments in the coordinate plane. Instead of just on a number line, now it's on the XY axis, right? On those kinds of things. So the midpoint part is almost identical to what we have done so far. The only difference is you'll do it twice. Once with the X coordinates and once with the Y coordinates. That's the only difference. So don't get all, like, this is so different. No, it's not. It's just once with the X's and once with the Y's, because the X axis is a number line and the Y axis is also a number line. So how do I know I'm supposed to be using that formula? Anytime you see the word coordinate and midpoint in the same problem, you immediately know I'm using this formula. The midpoint is equal to half of endpoint 1 plus endpoint 2. We've been using that quite a lot. Hopefully you have that one memorized by now. We're just going to do what we're going to do once for the X's and once for the Y's. So it tells me the coordinates of A are given here. The coordinates of B are given here. It says find the coordinates of the midpoint. Okay. So we're trying to find the midpoint, and A and B are the two endpoints. We're just going to do it, like I said, twice. Once for X and once for Y. So for X, we're just going to use the X coordinates. The midpoint for the X is going to be equal to half of the sum of the two endpoints, which are negative 14 and negative 6. No, it's negative 6. Yeah, make sure that you're using the X's, not, we're going to use the X coordinate out of both of these. Okay? No, it's one of the easiest mistakes to make is to use the X and the Y out of the same point. So that's going to be half of negative 20. Half of negative 20 is negative 10. That's the X coordinate of my answer. My answer is going to start with negative 10. And then for the Y, same thing, except I'm using the Y coordinates. The midpoint's coordinate is going to be 1/2 of 7. That's the Y coordinate for this point, plus negative 4, the Y coordinate for the second point. That's half of 3, which is 1.5. As a reminder to everyone, when you're writing coordinates, you must have parentheses around them. There were some questions about that on the quiz. I did not take off this time, but I will. Coordinates must have parentheses around them, or it's just two numbers separated by a comma. All right, so that we have plenty of time, we're going to skip this one. It's exactly the same as the previous one. Okay, we're finding the midpoint. And we're just going to do one of these also, just so we have plenty of time for the other one where it is more complicated. So it says here, J is the midpoint of segment MT, and it gives you the coordinates of J. And it says, so notice, midpoint, coordinates. As soon as you see both of those words, you know what equation you're going to be using. You're going to use the midpoint is half of endpoint 1 plus endpoint 2. Every single time. We're going to do it twice, once for x's and once for y's. So 4x. Do we know the x coordinate of the midpoint? Well, let's see. J is the midpoint and has coordinates -7, 11. So -7 is the x coordinate of the midpoint. The segment is MT, so the two endpoints are M and T. Well, M is one of the endpoints. Its x coordinate is -12, so this will be half of -12 plus, since it's x, I'm just going to call it x right here because this is the x coordinate. Terrence, you with us? So anybody tell me what I should do next to solve this? Wow, lots of volunteers. Max?
Times both sides by 2.
Yeah, we're going to multiply both sides by 2 because that gets rid of the 1/2 for us. And we don't have to worry about any fractions. So that's going to be -14 is equal to the 1/2 times 2 is 1. So we just have -12 plus x. Add 12 to both sides. Since we're adding a positive and a negative together, we'll subtract. It gives me 2, but the negative was bigger, so this is -2 is my x coordinate. And you don't have to label these 4x and 4y. I'm just doing that so it's clear what I'm doing. Okay? So substituting in, J is the midpoint. All right, and its coordinates are -7, 11. So 11 is the midpoint in terms of the y, is equal to 1/2 of the y coordinate of M, which is one of the endpoints, is -5. And I want to know the y coordinate for the other endpoint, so I'll call it y. We'll do this exactly the same way. We'll multiply both sides of the equation by 2. So that the 1/2 and the 2 multiply together to be 1. So that's going to give me 22 is equal to -5 plus y. Add 5 to both sides. And we have 27 as the y coordinate. So my answer is the coordinates -2, 27. So if you were good with the coordinate and midpoint problems that were on the homework last night, you should be good with this. It's just, again, you do it once for the x coordinates and once for the y coordinates. Everything else is the same. All right, and as I said, we're going to skip over that second example. So let's go on to the one that is a little bit more complicated. So here we're going to try to find the length of a segment in the coordinate plane. So this first part is just a reminder. If you're finding the length of a segment on a number line, if it was on a small number line, we could just count the spaces. Or we can subtract the two coordinates. So like here, we can either count 1, 2, 3, 4, 5, 6, and say the length of EC is 6. Or we can say the length of EC is 2 minus -4. So it's 2 plus 4 is 6. When you have a number line and they're that close together, you probably are just going to count it. I mean, let's be honest. You could do the subtraction, but we're all better at counting than we are at any other kind of mathematical operation, I think. Here, on a number line, if the coordinate of r is 15 and the coordinate of s is 39, notice this talks about coordinates, but it doesn't talk about midpoints anywhere, does it? So you don't use that midpoint formula. We're just going to subtract the coordinates. The length of rs is going to be 39 minus 15, which is 24. On the coordinate plane, it's not quite so easy. So let's take a look. Let's find the length of CD, and I'll show you how you can do this. If it's on a graph, there's a pretty easy way to do it. What I want to do is create a right triangle that has this side as its hypotenuse. You can do it above or below. I almost always do it below just because that's my habit. There's nothing wrong with doing it above. So what I'm going to do is I'm going to draw over from this point to here and down from this point to there so that I have a right triangle. And if I have a drawing like this, I'm simply going to count. This is 1, 2, 3. This vertical distance is 3. The horizontal distance going side to side is 1, 2, 3, 4, 5, 6. So then, what I'm going to do is do the Pythagorean theorem, which you learned in middle school. You may have forgotten it, and that's okay if you've forgotten it. The Pythagorean theorem says that if the sides of a right triangle are A, B, and C, where C is the hypotenuse, A squared plus B squared gives you C squared. So here, that's going to be 6 squared plus 3 squared is equal to CD squared. This is 36. This is 9. I'll add those two quantities together. That's 45. So CD is the square root of 45. Yes, sir. So that square root doesn't have a whole number, but we will simplify the square roots later on, but not right now. For right now, this is enough. I don't want to pile too much on you at once. All right. So for this one, it says find f, g, and j, k. And I swear to you, there will be somebody at some point who will say, what do you mean find it? I mean, find, who can tell me what this stands for when it doesn't have the bar over it? What does it mean? The length. Find the length of segment FG and the length of segment JK. I'm going to do exactly the same thing I did a moment ago. I'm just going to draw on this little right triangle. Across here, that's 4. Up and down here, this is 3. So 4 squared plus 3 squared is equal to FG squared. That's 16 plus 9 is FG squared. So 25 is FG squared. So FG is the square root of 25. And this one, we all know what that is, right? What's the square root of 25? 5. So I will ask you to go ahead and simplify that when it's a whole number. So let's see how long JK is. Now, just looking at it, it looks like it's about the same length. And it's close, but let's see if it's actually the same length. So I'm going to draw on a right triangle. And again, I always draw them below. If you want to draw it above, doesn't matter. I'm going to count. This is 1, 2, 3 here. This is 1, 2. This is 3 here also. I already know this isn't going to work out because on the other one, the sides were 3 and 4. And here they're 3 and 3. But let's go ahead and find the length. So it'll be 3 squared plus 3 squared is equal to JK squared. So it's 9 plus 9 is JK squared. 18 is JK squared. So JK is the square root of 18. Be sure to answer the question. Are the segments congruent? No, the segments are not congruent.
What do congruent mean?
Same size and the same shape. So for segments, all segments are the same shape, so they have to be the same length. Now, before we go on to the back, let's look back at where we found CD. Let's look at the x coordinates. -2 and 4. If we didn't have a sketch of this where we just counted the spaces, how could we get that this length was 6 from -2 and 4? I'm sorry?
Multiply them?
No. -2 times 4 is -8.
Oh, I didn't see it was
Yeah?
You can do the equation where it's like x minus x.
Yeah.
And,
What if we just subtracted? What's 4 minus -2?
that would be 6.
That would be 6. And then does that work for the y's also is a good question. So I've got 2 and -1. If I do 2 minus -1, do I get 3? Yeah. Let's double check to make sure that works on this one. Because just because it works once doesn't mean it's going to work all the time. So G is here at 5, 5. And F is here at 1, 2. 5 minus 1 is 4. 5 minus 2 is 3. Oh, okay. So we could do this without a picture. And when you put it all together, you get this thing called the distance formula. It looks horrible, right? This is a pretty ugly thing. But if you think about what's going on, it's not so bad. Here, we're just subtracting to find out how far apart they are horizontally. And then we just subtracted here to find out how apart they were vertically. Then we put it into the Pythagorean theorem, and we had to take the square root at the end. This just puts all of it into one formula. So let's use the distance formula here. It says find the length of JK given the coordinates of J and the coordinates of K. So let's show how that's going to be. The length of JK is going to be equal to the square root of, It doesn't matter which one is x1 and which one is x2. I'll say that again. It doesn't matter which one is x1 and which one is x2. For me, to make it easier on myself, I always pick the bigger one to be x1, or excuse me, x2, and the smaller one to be x1. So this is going to be 3 minus negative 2. And square it. Plus, for the y's, I've got 10 and 4, so I'm going to do 10 minus 4 squared. Three minus negative 2 is 5. 10 minus 4 is 6. This will be the square root of 25 plus 36. It's the square root of 61. On your assignment tonight, it's going to say, use the distance formula and the Pythagorean theorem. I'm going to give you your choice. If you want to do it by the distance formula, great. If you want to take the time to graph it and then do the Pythagorean theorem, you can do that also. It is your choice. So on homework, when you see that, think or. You can do either one. If you're more comfortable with graphing it and then counting the spaces, great. I don't have the patience for that, honestly. It takes too long to graph it. And if you graph it, make sure it's on graph paper, all that kind of good stuff. All right. I want to give your quizzes back. I know there's another example there, but I want to make sure you see your quizzes. So